I'm going to be discussing Table 1 from the paper titled Turning Riboflavin-Binding Proteins into a Self-Sufficient Monooxygenase by Cofactor Redesign. The purpose of the experiment in the paper was to determine whether monooxygenases could be prepared by cofactor design and decide if it's a viable approach to creating these artificial enzymes. They claimed that by cofactor redesign, several artificial flavoenzymes were created that function as peroxide-driven monooxygenases, capable of enantioselective self-oxidations. So we'll look at the data in Table 1 and see if it supports their claim. So this first column over here on the left is entry, and these numbers represent the number of tests that took place, so each entry is a different test. In these tests, the synthetic flavoproteins that they created were being tested for whether or not they could perform peroxide-driven self-oxidations. This R1 and R2, these R groups, these represent the different side chains on the sulfides that were used as substrates for the flavin. And then this flavin column, the different numbers represent different flavins used, so they had different shapes of flavins that they created, so 2s are one shape, the 3s are one shape, 4s are a different shape, etc. The plus and minus signs in this protein column represents the presence or absence of protein, so the plus represents the presence of protein, and if it's negative, that means there's an absence of protein. The two columns on the right, these present data that was collected during their experiment, while these columns over here were data that was used to perform the experiment, and then this is the results over here. So this first column represents the conversion percentages of sulfides being converted into sulfoxides. So the percentages were measured by, it says down here, GC, which is gas chromatography. And then this final column, this indicates the percentage of the excess product being produced by the experiment. So the excess was either R sulfides, represented by this R here, or the S sulfides, which is here. So the R excess was produced by flavins 2, and then down here 6. And then all of the S sulfides were produced in excess by 3, 4, and 5. Overall, the data showed that riboflavin-binding proteins and artificial flavins are capable of being self-sufficient monooxygenase. Using different types of flavin can yield different results, depending on what sort of excess you're looking for. The R's or the S's, you can use the different flavin numbers and shapes. And we know that these results show that the artificial flavoenzymes can function as peroxide-driven monooxygenase capable of sulfooxidations because all of the flavins in the data are converted from sulfides to sulfates. So these last 3 entries down here, they're kind of incohesive with the rest of the data, but we can consider them to be as controls because, like for example, here there's no flavin used, and they all use the same R1 and R2 groups, so these are basically just the controls of the experiment, and that's why they're not cohesive with the data that shows that the artificial flavoenzymes can be peroxide-driven monooxygenase that are capable of sulfooxidations.